Alright, first step, game manager is a singleton. You can see void start. If the variable instance is already defined, then it will destroy itself. Otherwise, it will set itself to be the variable instance of game manager. It will set destroy unload, and it can start doing all that wonderful stuff that it wants to do. Alright, next step. Game manager is an FSM. So you can see the finite state machine for the game states is right here. Or this is just the states for the finite state machine. And then if we go to state start, you can see when you start a state, it initializes that state, and it has a swap state here. This is just how I set up my finite state machines. And then the lists. Oh boy, do we got lists. Oh boy. We have lists for all the players, all the controllers, all the pawns, all the spawn points that can be used every room, active cameras, active noises. Yeah, all sorts of lists. This is the code for the spawn points that creates the pawn and the controller pair. And you can see right here, after they're spawned in, they have their variables initialized. They are linked to each other. This is a pawn controller pair. And what's really important about this pair is that you can see here the pawn and controller these are all our controllers, and this is the tank pawn. The bullet isn't a pawn, it's just, look. And so what's important about the pawn controller pattern is that all the things that the AI is trying to do are separate from what the pawn decides what the AI is able to do, right? The AI can tell the pawn whatever it wants, but the pawn limits what the AI wants to do to what is possible in the game, and that prevents like AI bugs causing like impossible behavior. At least that's kind of how I look at it. I think it makes it easier to code in a way that doesn't cause like weird shit to happen. Inheritance means that you have this base class of object with this, for example, take like this spawn function. It does a lot of stuff here, right? But what's important is that the versions of spawn point can just take all of this base structure and make whatever changes to that structure they want for their specific purpose. So, for example, all player spawn point really needs to change is just make sure that the team is set to the player team. And the defender spawn point actually has a different spawn routine, because what it has to do is use the base spawn function, but then get its AI and add the patrol points that are in the spawner to the controller. So that is an example of implementation of inheritance. So pawns can use one of two health display systems. They can use this health display up here, called the UI health display. They can use that health display down there, called the local health display. And what's so important about the component pattern is that this health component, because all of the components are completely separate from each other, even though the local health display is a part of the tank pawn, and the UI health display is part of a completely different thing. The health component has no idea about any of that. It's just calling update health bar, and because the other components are handling how to interpret this command, everything just works great, and I don't have to update the health component at all when I change what health bar the things are using. And I don't know why I closed that, but that's an example of components. As an example of a timer, we have sense update. Because the senses don't run every frame, it just checks if the last sense update plus the sense update interval is smaller than time.time, and if so, then it does the sense updates. Updates the sense time to reset the timer, and bada boom, bada bingus, we're done. Alright, next up, start and game over screens. So this is the title screen. You can press any button, Then I'm going to start. And now I am going to die. That error was because I used the debug command too many times. But yeah, there's the game over screen. Alright, so you can see that's an image right there. That's the buff I have. My health bar is also an image. You can see my score right there is displayed on the screen as text.
Take him by sleep.
My live stream. So that's examples of images. And you also saw my health bar was a screen space canvas, and the guy's health bar was a world space canvas. The health component has two important features. The location of the health display, matching the side of the screen that the player is on, and the location of the bar actually changing to be on screen. So, in order to implement this, you'll notice that the bar, this health component itself, has two pieces, the heart and the bar. Now, the heart always stays centered on the thing, but you don't want the bar overlapping the heart, because then it would look ugly. So, what I do to make sure that it doesn't overlap the heart is I set the anchored position. This is what the anchor is for. I slide the anchor over here, and then boom, now the heart's over here. But we're not quite done yet, because when the health goes down, it's going to go down like this, and that doesn't look good at all. So, if you change the pivot point, you can see now when the health goes down, it goes down like this. It's much better. And that's because the pivot point is controlling the center that the scaling is happening from. You can see. So that is the difference between the anchor and the pivot. Alright, hello. So I'm on the main menu here. I can go to options. You can see is a lot more than the bare minimum here. Have the sound slider that controls whether or not this makes noise. Have generation settings. If I turn that down, you can see the music there. An example of changing camera settings. When there are two players at the same time on different screens, I call this the cameras being in twin state, because there are two cameras acting as like a pair of cameras. And so if they're in twin state, it sets the camera rect to only take up half the screen, slightly less than half the screen, so that there's actually like a little border between the cameras. And then when they exit twin state, it sets the cameras back to full screen. Alright, so you can see here, this is a tank support, this is a tank patrol. This support is trying to reach the patrol here. You can see that it is patrolling with a seek, and now that it's dead, this guy is fleeing from me using seek. But it found a new friend, so now it's attacking me. So that demonstrated sight, and that demonstrated sight and fleeing and patrolling. And now to demonstrate seeking and hearing, that guy right there just heard me shoot. He's going to come around right here, and he's going to kill me. And you can see that they're seeking me. An example of the game using a trigger, each room just has a massive trigger that covers the whole area. Whenever a pawn touches a new trigger, it triggers this trigger, which tells the camera to update the cameras for the players. And additionally sets that pawn's room location. Alright, rapid fire. Fuck. 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 Time. Delta time. Boom. Transform. Rotate. Boom. Rigid body. Move position. Rigid body. Move position. Boom. Key code. Key. Get key down. Boom. Get key. Boom. Let's go. And finally, key codes exposed for designers. I'll do you one better. Key codes are exposed for the player. Oh! Oh! Fucking got him! Alright, so you already saw instantiation in the spawn function. You can see right here I destroy objects. Right here for each, it automatically goes through each of the, you give it an array and it goes through each of the things in the array and does whatever you put in here with that this value representing that index of the array. Then it uses a for loop, which lets you define a number when the for loop ends and what to do to the number each loop. It uses that in order to go through each of the remaining spawn points left in the spawn points array and choose a randomized spawn from it. Alright, and now I'm going to explain what an int, a float, a string, a list, and a class are in one take, and I'm going to get it wrong, and it's going to be funny because I'm really tired. So an int is just a number, but it can only be whole values. A float is a number, but it uses a 32-bit index thing to be lots of values that are like decimal values. A string um, is like text. Strings are text. Very useful to be able to put words. A list is a C# thing. When you use lists, you want to go to, you want to Google search C# list methods, and then use this, that's what lists do. Class is you know how like inheritance it has that. The class is how you define the inheritance and also the thing that the thing does. Easiest shit. Fucking baby hours. I'm the greatest programmer of all time.